All right, for Algebra 2 today, we are starting elementary matrix operations. Okay, so we are breaking this into 2 days, as you can see. So we're going to, if we look at our objectives that apply today for us, all right, we are going to add and subtract matrices, identify the additive identity and the inverse matrices, and we're going to perform some scalar matrix multiplication. Okay, those are today's 3 objectives. And then we're going to build on that tomorrow in class and solve matrix equations. We might solve one today so you can kind of see what's coming. It all kind of flows together, but we won't actually start them. We'll go over some more tomorrow and some word problems, and then we'll have some time in class tomorrow to work on those. So just those first 3 objectives today. Okay, so first of all, let's look at the definition of equal matrices. Okay, so equal matrices have the same dimensions. They have to have the same dimensions. So a 2 by 3 and a 2 by 3, or a 3 by 4 and a 3 by 4. And they have to have equal corresponding elements. Okay, so those elements in the same relative position. So this is kind of cool. If we look in this example, okay, we see that we have equal matrices. This is going to be really helpful when it comes to solving equations. So we have A is corresponding to 7. So that means that A equals 7 is what that means. So what are some other corresponding elements? Okay, hopefully you said 2B is corresponding to -8. Okay, they're in that same relative position. Or maybe you said 3 corresponds to C minus 5. Okay, they're in that same relative position. Or maybe you noticed 3D is corresponding to D plus 6. All right, so that's cool because we can solve for these. So we could say, well, 3D has to be equal to D plus 6 because they're equal corresponding elements, or because these are equal matrices. They have to be equal. So that's pretty awesome. They're the same dimensions and the corresponding elements are equal. And we're going to use that in example 1. Okay, example 1 says, find the values of A, B, C, and D such that, and we have this matrix. I'm going to move this on up a little bit. Okay, so we know, we already did it, A equals 7. Okay, great. So 2B corresponds with -8, so we can set up this equality, or this equation, whichever you want to call it. 2B is equal to -8, and we can solve that. We can divide by 2 on both sides, and we get B is equal to -4. Haha, awesome, right? Okay, let's do the next one for C. So the next set of corresponding elements is 3 is equal to C minus 5. Those are corresponding. I should have circled them instead of outlining them. Okay, but to solve for C, we're going to add 5 to both sides. So then we get 8 is equal to C. So again, we're picking out those corresponding elements. So for D, 3D is in the same place as D plus 6. So we're going to say, well, 3D equals D plus 6. So to solve, we would subtract D from both sides, and we'd have 2D equals 6. What now? Good. Divide by 2, and D equals 3. Perfect. All right, so you just took that idea of equal matrices and used that to solve for the elements. So very, very nice. All right, then we're going to look at addition and subtraction. Okay, so let me clear this and move it up so we get the whole page on there. All right, addition and subtraction. Only matrices with the same dimensions can be added. Okay, so they have to have the same dimensions. And to solve them, we add or subtract, whichever one we're doing, the corresponding elements. So just like we use that to solve, that idea of corresponding elements, that's how we're going to add and subtract. So I've started example 2. If we're given A equals this matrix, and matrix B is this one, we want to evaluate each expression. So in A, we're doing A plus B. So I wrote A, just copied it down, and plus, and I copied down B. So it says to add or subtract, though, we add and subtract the corresponding elements. So this is addition. So corresponding elements are 2 and 4. So that's why this first place says 2 plus 4. The next element is 7, and this one is 2. So that's why this middle, like first row, second column, is 7 plus 2. And then next we have 0 and -1 are corresponding, so we add them here. 0 plus -1. We keep going. So 3 plus 1, that goes here. It's in the same, we put it in the same spot it was in previously. Let's do 1 and -2. So then we have 1 plus -2. And our last one is 5 and 8. Those are corresponding. So we have 5 plus 3, pardon me, 5 and 3. And so 5 plus 3 here. Sometimes I do the math in my head and I skip ahead. All right. So then we actually solve those. Okay, so 2 plus 4 is where we got 6 from. The 7 plus 9 right here, or 7 plus 2, see I did it again, did the math in my head. 7 plus 2 here is where the 9 came from. The 0 plus -1, that is where the -1 came from. Hopefully you're picking up on, like you're getting this. So 3 plus 1 is where my 4 came from. 1 plus -2, well, that's -1. And our last one, 5 plus 3, well, that's 8. And that's where that number came from. So I'm taking this bit by bit, piece by piece, and it seems like a lot of work. But again, this is a shortcut to solve a system of equations. And you are solving lots of systems. Okay, you're actually, in this case, you're adding 2 systems together. So crazy, right? We're past the solving part and we're adding 2 systems. So that's pretty awesome, because otherwise you'd have to solve 2 different systems and then add them together and solve again. So it's actually a shortcut. It just seems like it takes a while. Okay, so that's a lot of circles. Hopefully it made sense, and we're going to try it in B. Only this time we're going to take A minus B. So I've copied A down, 270,315 minus 42, -1, 1, -23, because we're going to do subtraction. All right, so this is going to equal. And you don't have to show this, all these, like this step necessarily in your homework. It might be helpful for a while, but I'm going to show it so you can follow what we're doing. So we're subtracting corresponding elements. So 2 minus 4 is going to go here. In the middle, we're going to have 7 minus 2. Good. Hopefully you're saying the number as I'm writing it. For the next one, I have 0 minus -1. Let me put my parentheses back around that. Okay. For the next row, so we're going to start at the front. So we're going to have 3 minus 1. Then we'll move to the middle number, 1 minus -2. And we'll move to the last number, or element. So 5 minus 3. Okay, and let's simplify this. So 2 minus 4 is -2. 7 minus 2 is 5. And 0 minus -1, well, that's the same thing as plus, so this is 1. All right, I usually work across the page, just like you're reading. There's no right or wrong, but just make sure you're putting them in the right place. 3 minus 1 is 2, so I'm starting the second row. 1 minus -2, so that's the same thing as plus. 1 plus 2 is 3. 5 minus 3 is 2. So there is our solution, or our answer to that matrix. We have negative 2, 5, 1 for the first row, and 2, 3, 2 for our second row. Okay, so we've just done addition and subtraction. We're well on our way in our lesson here, so very nice. Okay, so next, we'll talk about these matrices have an additive identity and an additive inverse, just like real numbers. So I kind of made this chart. It's not in your book, but to help us out. The additive identity in real numbers says that A plus 0 equals A. So the additive identity is when we add 0, we still get A. Well, okay, that's in real numbers. Well, in the additive identity in the matrix is the same thing. It's a matrix with all zeros. Okay, it's also called a zero matrix. So this first one is called a 0, 2 by 2, okay, because that's what size it is. But it's full of zeros. We have a 0, 3 by 1. It's full of zeros. So there's 3 rows and 1 column. A matrix 1 by 4, it's 1 row with 4 columns. Okay, an additive identity matrix is a matrix with all zeros. That's all that it is. And it's going to be named, right, just like a matrix, but it's 0 and then the rows by how many columns. Okay, so let's check out the additive inverse. Okay, so in real numbers, the inverse says A plus negative A equals 0. The goal is always to get that 0 in the additive inverse. Well, the additive inverse matrix, okay, in the matrix, each corresponding element is opposite. Okay, so each corresponding, but that's key right there, each corresponding element is opposite. So matrix A plus the inverse of matrix A has to equal 0. So if, in our example, if this is matrix A, okay, it's a 2 by 3, all we do is we take each element and we make it the opposite in the inverse matrix. So the opposite of 2 is negative 2. The opposite of negative 1 is 1. You'll notice the opposite of 0 is still just 0. Okay, but this one, we always put a negative in front of it, is called the inverse matrix. That is the inverse matrix. Because when you add them together, you're going to get 0. All right, then let's move to example 3. All right, it says state the additive inverse and additive identity of each matrix. Okay, so C is done for you. All right, so here's what we start with. All right, C is a 2 by 3 because there's 2 rows and 3 columns. But again, we want the additive inverse, so we want the negative C. So we have the opposite of each of these. The opposite of 1 is negative 1. The opposite of 0 is 0 because it doesn't really have an opposite. The opposite of negative 6 is 6. The opposite of 9 is negative 9. Opposite of negative 2 is a positive 2. The opposite of 5 is a negative 5. And then we want the additive identity, so that's 0. It's not going to, what matrix is not going to change the identity of C? And so we have to make it the same size, so it still has to be a 2 by 3. And we just fill it with zeros. All right, so let's try this with B. So in this case, our matrix is M. It's a 3 by 2. Okay, and let's take each of these. What's the opposite of 8? Good, negative 8. What's the opposite of 7? Negative 7. Perfect. What's the opposite of 6? Negative 6, good. The opposite of negative 5, positive 5. The opposite of negative 4, positive 4. The opposite of 3, negative 3. And there you have it. Okay, this is the inverse matrix. All right, and the identity matrix is full of zeros. Again, this is an identity matrix. It's going to be a 3 by 2. Has to be the same size. So we have 0, 0, 0, 0, 0, 0. Ta-da! So much fun there, right? So much fun. All right. The other cool thing is the addition of matrices is associative and commutative. So, I mean, solving these matrices is a lot like balancing an equation, and we're going to get in that. Actually, it is just like balancing an equation, only tweaked a little because it's a matrix. And we'll get into that more tomorrow. All right, so now in our objectives, we're moving down to, we're going to be on objective 3 with multiplication. Okay, so multiplication. The real number factor is called a scalar. So that's this number right here. All right, and we're like distributing the scalar to absolutely everything inside. So if we start with this 3 times the matrix, 2, negative 4, 0, 7, we distribute it and we say, well, 3 times 2, that's where this number came from. And then we say, well, 3 times negative 4, and we wrote that here. Then we have 3 times 0 right there in that same corresponding position, and 3 times 7, again in that same corresponding position. And then we solve it. 3 times 2 is 6. 3 times negative 4 is negative 12. 3 times 0 is 0. And that last one, 3 times 7 is 21. So the corresponding positions, everything goes in a corresponding position. So this is called scalar or scalar multiplication, depending on how you want to pronounce it. Okay, but it says the scalar product. So the scalar product is R times A. So R is the scalar, A is the matrix. Remember, because the matrix is named with a capital letter. So the product, scalar product, R times A, of a real number R and the matrix A is found by multiplying each element of A by R. That's what I just showed you up here. We're multiplying each element of the matrix by the number outside, by the scalar, or the R. Okay, so let's look at example 4. Given A, or matrix A is 4, 0, 2, 5, so it's a 2 by 2, and matrix B is 2, 4, 1, 3. Evaluate each matrix expression. Okay, so let's look at this first one, example A. So we want to take 1/2 of A, matrix A. So I wrote down 1/2 matrix A equals, and I kind of, again, like showing the work, I'm showing part of the work. I didn't copy the whole thing, but I'm showing part of the work. So we're going to take 1/2 of 4 because that's the first number. And then 1/2 of 0 because it's next. 1/2 of 2 because that's the number here. And then 1/2 of 5 because that's the next number. And then I simplify that. 1/2 of 4 is 2. 1/2 of 0 is 0. 1/2 of 2 is 1. 1/2 of 5 is 5/2. So this is my final answer. 1/2 of matrix A equals 2, 0, 1, 5/2. So I'm just distributing that. Okay. So let's give B a shot. Okay, this one says B is negative 5B. Is that negative 5? So that's what we're distributing. We're multiplying negative 5 by each element of B this time. So we have negative 5 times 2, negative 5 times 4, negative 5 times 1, and negative 5 times 3 right here. Oh, and I didn't close that. You might close that matrix. I missed that. Okay, so now I've done that first step for you. I want you to tell me what the answers are. So for this first place, right, negative 5 times 2 is, good, negative 10. Next, we're going to move to the right. Negative 5 times 4, excellent, is negative 20. All right, second row, negative 5 times 1, good, negative 5. And right on the second row, negative 5 times 3, good, is negative 15. So negative 5 times matrix B equals negative 10, negative 20, negative 5, negative 15. All right. That's really all you're going to have to do in your homework today. But we're going to go ahead and do C. It's a bit more complicated, but I want to go ahead and show it to you. I think it would be fresher in your mind maybe if we go ahead and look at this one, because most of the work is done for you, but we can talk about it, okay? Because there's a lot going on in C. All right, in C, we have that we're taking 3 times A, and this is minus 2B. So we need to, it says what happened in C. So let's talk about that first. So first of all, we need to multiply, maybe I should put what happens. We need to multiply matrix A by 3. And here we need to multiply matrix B by 2. Or you could choose to do negative 2 and then add them, but I'm not going to do that. Okay, that might have been a better way to do it, but I want to look at the subtraction part. So you could kind of choose which other. You could multiply by a negative 2, totally fine, or multiply by 2 and then subtract. In your homework, you can do it any way you want, because in my homework, I would probably do negative 2 and then add. But I'm going to work it out the way the textbook did to keep it consistent if you go back and reference it. All right, so we multiply matrix A by 3, we multiply matrix B by 2, and then the next thing we do is subtract. So we're going to subtract last. All right, so let's get into this, because it's actually pretty cool when we see how we can do all this. It's pretty awesome. Okay, so I went ahead and wrote down what we're going to do. We're going to take 3 and multiply it by matrix A, because I don't want to have to keep looking back. And we're going to subtract 2 times matrix B. Okay, I copied that down so I didn't have to go back and look. All right, so first of all, I need to start that distributing the scalar kind of. So we have 3 times 4, 3 times 0. In the second row, we have 3 times 2 and 3 times 5. And then we're going to distribute the 2 to matrix B. So in the first row, I have 2 times 2 and 2 times 4. In the next row, I have 2 times 1 and 2 times 3. All right, this next step, I just simplified. Right, I showed my work. Here I have my work, and now I'm going to simplify. So 3 times 4 is 12. 3 times 0 is 0. 3 times 2 is 6. 3 times 5 is 15. I bring down my subtraction sign, and I'm going to simplify again. 2 times 2 is 4. 2 times 4 is 8. 2 times 1 is 2, and 2 times 3 is 6. So I've simplified. Now I'm ready to show my work for subtraction. Okay, so there's my work again. Again, when we're doing addition and subtraction, we're looking at corresponding elements. That's what we subtract. So this first one is 12 minus 4. My next set is 0 and 8 are corresponding. So I have 0 minus 8. Then I move to the second row. 6 and 2 are corresponding. So I have 6 minus 2. And the last one is 15 and 6. So I have, oh, why do I have 2 minus 6? I copied the wrong number down. So let's fix that. That's 15 minus 6. Okay, and we need to simplify. Again. Okay, so let's get started. 12 minus 4, good, is 8. 0 minus 8, excellent, is negative 8. 6 minus 2, perfect, is 4. And 15 minus 6, good, is 9. So this is your final answer. You did scalar multiplication for both problems, or for 3A and 2B. You did your scalar multiplication. Then we did subtraction, and we got our answer. So I know it seems like a lot of steps, but again, in this case, like, matrices are a shortcut to solving systems. So each of these is a system, right? This is 2 separate equations. So you just multiplied 2 equations, or like the system, by 3. You multiplied another system by 2. And then down here, you subtracted those 2 systems from each other, and you got one system, one set of answers for that system. So you've done a lot of work in a very small space and in a rather short amount of time to think that we're working with systems, which was the chapter we just finished. Okay, so you're doing a ton of work. Okay, so we're going to stop there for day 1. We don't want to overwhelm you too much. So your exam or your homework tonight is 1 through 12 all. So I do want you to do the evens. Make sure you're checking your odds in the back of the book, but do make sure so that when you're doing the even ones, you feel more confident. Okay? All right, I will see you tomorrow, and we will finish up matrix operations and look at solving them. We'll look at that 4th objective. Okay, so solving matrix equations. It'll be pretty exciting, I promise. Okay, I'll see you tomorrow.